discussed criteria of good estimator. What are the four conditions for an estimator to be good estimator? It should be unbiased estimator, it should be consistent, and it should be efficient and sufficient estimator. So these are the four conditions to be satisfied to call an estimator as a good estimator. When do you call an estimator as an unbiased estimator? If expectation of t is equal to theta, we call that t as unbiased estimator of theta. Second one, when do you call an estimator as a consistent estimator? Whenever t converges in probability to theta. That is, if at all E of t is equal to theta and variance of t approaches to 0 as n turns to infinity, we can say that t is a consistent estimator of theta. So now we are going to discuss the third criteria, which is called the efficiency of an estimator. So as E of t is equal to theta, we call that as an unbiased estimator. If t converges in probability to theta, that is E of t is equal to theta and V of t turns to 0 as n turns to infinity, we call that as consistent. So what is the condition for an estimator to be efficient? Means whenever you consider two estimators for theta, let us say that you have two estimators T1 and T2 for the parameter theta. So to call these two, to call one of the estimators as an efficient estimator for theta, first condition it should satisfy is it should be an unbiased estimators of theta. So E of T1 should be equal to theta and E of T2 is equal to theta, and this is the primary condition. The second condition should be that variance of, if at all variance of T1 is less than variance of T2, means here when in the second condition you should compare the variances. Whenever the variance of first estimator is less than variance of the second estimator, we call T1 is efficient estimator of theta. So if not, variance of T2 is less than variance of T1, then we call T2 is efficient estimator of theta. So when do you call an estimator as efficient? Means it, first of all, it should be an unbiased estimator. Once it is an unbiased estimator, then you should check that you should compare the variances of the estimators. The one with minimum variance is called efficient estimators. Means the definition is, in a class of unbiased estimators, the one with minimum variance is called efficient estimator. Always efficiency is related to the variance concept. The variance should be minimum. The one with minimum variance is called the efficiency of an estimator. Let us do a problem. Let us do problems on that. Let x1, x2, x3, x4, x5 be a random sample drawn from n mu sigma square population. Okay, what is the sample size here? 5 is the sample size. x1, x2, x5 be a random sample from n mu sigma square. Now consider the following estimators. T1 is equal to x1 plus x2 plus x3 plus x4 plus x5 by 5. T2 is equal to x1 plus x2 by 2 plus x3. T3 is equal to 2x1 plus x2 plus lambda x3 by 3. So you are given with 3 estimators. Now you need to check. The question is check T1, T2, T3 are unbiased estimators of mu and find lambda such that T3 is unbiased estimator of mu. Find the most efficient estimators. Now you are given x1, x2, x3, x4 is a random sample from which population? Normal population with parameters mu comma sigma square, and you are given three estimators T1, T2, T3. Now the question is, check whether T1, T2, T3 are unbiased estimators of mu. You should check whether these three are unbiased estimators or not. And if you observe, you have unknown constant lambda here. You should find out lambda such that T3 is an unbiased estimator of mu. Given T3 is an unbiased estimator of mu, using that condition find lambda. And also find the most efficient estimator or efficient estimator among these three. Now, so it is given that x follows which distribution? Mean mu comma normal distribution. And what does it mean? Mean of normal distribution is mu. Variance is sigma square. What is T1? T1 is x1 plus x2 plus x3 plus x5 by 5. This is the expression for T1. T2, T3 is this one. You are given these three. What are the questions for you? You should check that. First bit is to check whether T1, T2, T3 are unbiased estimators of mu. When do you call an estimator as unbiased? If at all E of T1 is equal to mu, E of T2 is equal to mu, E of T3 is equal to mu. Check these three. You need to not T3, you need to check whether T1, T2 are UE of mu. So let us find out T of T1, which is nothing but what is T1? x1 plus x2 plus x3 plus x4 plus x5 by 5. As 5 is a constant, we can take it out of the expectation. E of x1 plus E of x2 plus so on E of x5. What is the mean of normal distribution? Mu. So E of x1 is mu, not mu1, all are mu only, mu plus so on mu. You have 5 mu, you are adding mu for 5 times, so 5 mu, which is nothing but mu. You got E of T1 is equal to mu. We can call T1 is UE of mu. Second one, what do you need to check? Check whether T2 is unbiased estimator of mu. That is, you should check whether E of T2 is equal to mu or not. What is E of T2? T2 is nothing but E of x1 plus x2 by 2 plus x3. So 1 by 2 can be taken out. E of x1 plus x2 plus E of x3. See, this 1 by 2 is only for the first term. 1 by 2 E of x1 plus E of x2 plus E of x3. What is the mean of normal distribution? Mu, as like the previous case. 2 mu, mu plus mu is mu plus mu. You got that as mu plus mu, which is equal to 2 mu. So E of T2 is not equal to mu. Clearly here E of T2 is not equal to mu. So whenever E of T2 is not equal to mu, T2 is not an unbiased estimator of mu. Now, what is the second bit you need to find out? Find lambda such that T3 is unbiased estimator of mu. You need to find out lambda such that T3 is, to find out lambda, you should make use of the condition T3 is unbiased estimator of mu. That is, it is given. You are not checking, this is given to you. E of T3 is equal to mu. What is T3 here? What is the expression for T3? 2x1 plus x2 plus lambda x3 by 3 is equal to mu. 1 by 3 can be taken out. 2x1 plus E of x2 plus E of lambda x3. To find out lambda, it is given it's an unbiased estimator. So by making the condition that E of T3 is equal to mu, I am going to find out lambda. So 1 by 3 is a constant, can be taken out. E of 2x1, again 2 is a constant, you can take it out. V of 2x1. Here lambda is a constant. 1 by 3. What is mean of normal distribution? Mu. Mu plus lambda mu is equal to mu. From all these terms we can take out mu common. You will get 2 plus 1 plus lambda is equal to mu. Mu cancels. You have 1 by 3 into 3 plus lambda is equal to 1. From this you will get 3 plus lambda is equal to 3. Lambda is nothing but 0. You got lambda value as 0. Then what is T3? T3 is, by substituting the value of T3, lambda is equal to 0 in that, you will get T3 is equal to lambda. So you have calculated lambda. One more bit is left, that find the most efficient estimator from these three. When do you say an estimator is a most efficient estimator? Whenever its variance is minimum. Okay, the one with, whenever the variance is minimum, we call the estimator as efficient estimator. So you are given with T1, T2, T3. First bit you have checked that T1, T2 are unbiased estimators or not. We have obtained that T1 is unbiased estimator but T2 is not an unbiased estimator. In the third bit they are given T3 itself is unbiased estimator. You need to find out lambda. So we have done that also. Third bit, you need to find out the most efficient estimator. How do you find out a most, when do you call an estimator as a most efficient estimator? Whenever the particular, in a class of unbiased estimators, the one with minimum variance is called most efficient estimators. So to call an estimator as an efficient estimator, first of all it should be an unbiased estimator. We have observed that T2 is not an unbiased estimator. So in the first one you can cross off T2. Now you consider T1 comma T3. Among these three, to say that a particular estimator, if at all we find out the variances, for efficiency always you should calculate variance. If at all V of T1 is less than V of T3, as we call T1 as efficient estimator. If at all V of T3 is less than V of T1, we call T3 as efficient estimator. What is the condition I said? The one with minimum variance is called efficient estimator. As you have three estimators, it should be an unbiased, it should be an unbiased, it should be an unbiased to check with variance. Clearly, this is not an unbiased estimator. So, the variances you should compare is nothing but variance of T3 and variance of T1. Compare these two. If at all T1 has minimum variance, this becomes the efficient estimator. If at all T3 has minimum variance, T3 becomes the estimator more efficient. Let us find out variance of T1. What is the expression for T1? T1 is nothing but x1 plus x2 plus x3 plus by 5. I said you that whenever a constant comes out of the variance, always it is squared. So 1 by 25, variance of x1 plus variance of x2 plus variance of x3 plus so on, variance of x5. What is the variance in normal distribution? Sigma square. Sigma square plus 5 times sigma square. Am I right? This is sigma square, sigma square, sigma square, sigma square, sigma square. You will get 5 sigma square by 25, which is nothing but 1 by 5 sigma square. Okay. So let us find out V of T3 also. What is T3 after finding lambda? 2x1 plus x2 by 3. As this is a constant, whenever it is taken out of the variance, it is squared. Variance of 2x1 plus x2. So 1 by 9. Again variance of 2x1 plus variance of x2. 1 by 9. This is 4 into variance of x1. Again this is a constant, 2 square 4. Variance of x2. 1 by 9. What is variance in normal distribution? 4 sigma square plus sigma square. So which is nothing but 5 sigma square by 9. So you got variance of T3 as 5 sigma square by 9. So to compare variance, what is variance of T1? How much you got? 1 by 5 sigma square. What is, let us convert this 1 by 5 into decimals. What is 1 by 5? This is 0.2 square. What is 5 by 9? 5 by 9 is nothing but what is the value of 5 by 9? 0.5. Okay, sigma square. Variance of T1 you got as 0.2 sigma square. Variance of T3 as 0.5 square. Which one is minimum? Which variance you got as minimum? 0.2. So as variance of T1 is minimum, we can say that T1 is efficient estimator. Okay, thank you.